In this video, we are going to review the coordinate plane and begin to talk about functions. So an ordered pair of numbers indicates where a point is on the coordinate plane. When graphing a point, the signs of a number indicate which directions to move along the x-axis and along the y-axis, starting from the origin. And remember that the origin is the point 0, 0, which is dead center in the middle of the coordinate plane. Remember your x, you move right if it's positive and left if it's negative. I'll draw you little arrows in case you're bad with your right and your left like I am. And then y is your up and down. So I always say x and y, walk and fly. So remember that x walks side to side and y flies up and down. So this is going to just be a quick review. I want you to practice plotting the points on the coordinate plane because this few lessons will do a lot with that. Remember you walk and fly, x and y, so I'll do an example for you. I'm going to walk 2 to the right from the center, always start in that center point. So I'm going to walk 2 to the right, and I'm going to go 3 down because it's -3, and there is my first point, and I'm going to put the number 1. I would like for you to try points 2 through 5. So here's your answers for those. It also wanted us to identify each quadrant. Remember, the quadrants go around like a C, so this is quadrant 1, 2, 3, and 4. So first point is in quadrant 4, the second point is in quadrant 2, third is in 1, fourth is in 3, and be careful with that last point, that one is on the y-axis. So now let's make this a little bit more complicated. Now we're going to actually start looking at lines, and it wants us to identify all 5 coordinates where the line intersects the grid perfectly. So we're looking for where the line makes a little plus sign right on top. So like right there is a point. Here would be another point. And if I keep following this up, here is another one that's perfect. It has to be perfectly crossing. And you can kind of see how they're getting spaced out. They're real even. So there's all my points. So let's write them on the in the table. So I'm just going to do this first one up here. So I'm at -5, +8. So I'm going to fill in the table, -5, +8. And then the next point right here is -1, +4. This one is 2, 0. 2 side to side, 0 up and down. This one is 5, -4. And then 7, -7, or 7, -8, I apologize, is the last one. Alright, so how does this relate to our next topic? So I've filled in some of the notes for you, so if you need to pause, go ahead. I'm just going to kind of talk my way through them. So relation is a set of ordered pairs, and we'll talk about this in form of relationships. And so in this example we have, this is a relation. It's made up of ordered pairs. So we have the point 4, 3, 5, 4, 0, -1, and 2, 1. And relations can be written as a function, which is the equation form of a relation, a table, or a graph. So we're going to look at all 3 different pieces of it. So we're just going to take the ordered pairs from up here in the example, and we're going to fill them into the table. So we have our first point, 4, 3, and then our next point is 5, 4, and 0, -1, and 2, 1. So we need to be introduced to some new vocabulary. The domain is the first numbers in the ordered pair, or all of the x values. So if we look at our example here in this table, the domain, what is the domain? Well, the domain is just a list of all the x values. Now, if you look in the example, the first example up at the top, you can see they made these nice pretty little brackets like this. To me, those are kind of annoying to draw. So I like to use lightning bolts to show my relation. I don't care what you use. You can use a squiggly line. You can try to make the nice brackets. You can use lightning bolts, whatever kind of makes you happy. Just make sure I know that it's called set notation. So I'm just going to write a set of all the x values for the domain. So I have 4, 5, 0, and 2. And then I'm going to do the range. The range is the second number for the ordered pair or all of the y values. So all I'm going to do is list them out. 3, 4, -1, and +1. So the range is all the y and the domain is all the x. And you can remember that because alphabetically, x comes before y. Same thing with domain. Domain starts with D. D goes before R for range. So now we're going to use those ordered pairs and we're going to create a graph of that same relationship. So we had a set, now we have a table, and then we're going to make the graph. So if our first point was 4, 3, and I'm using the points that are up in the table, so we're doing 4, 3. And then we have 5, 4, and then 0, -1, and 2, 1. So there's your graph. And anytime we graph on a coordinate plane, we're always going to make straight lines for this unit. So if you don't get a straight line, you're making a mistake. They're all proportional relationships. And we are going to draw a nice pretty straight line as best as you can. And if you'd like to get a straight edge or a ruler out, you can do that. Or use the side of your binder. And you always want your arrows to go off of the coordinate plane because the line goes on for forever. So we have our nice graph there. And that's the same graph as the numbers that are on the table and as the numbers that are in that set notation up at the top. Okay, so let's talk about a function. A function is a relationship in which each element in the domain, or all the x values, is paired with exactly one element in the range, or all the y values. So a hint in this is the x value cannot repeat. And that's the main idea of it. We need to be able to make a nice, pretty straight line with no x values repeating because that means they're going to overlap them. I'm going to show you what it looks like on a graph. An easy way for you to remember this, and I always giggle when I tell this example, but if you think as the x value and the y value, like they're in a relationship together, the x value cannot have more than one y value. So it can't have more than one boyfriend or girlfriend, because if it has more than one boyfriend or girlfriend, then that's why they become an x. So you can only have one x value paired with one y value in order for their relationship to function, because no one likes any cheaters. So there's my silly example for how you can remember. Your x cannot repeat, because if they repeat, they become an x, because they're cheating. So let's look at the example, and we're going to mainly focus on our x values. So are the examples functions? Are they functioning relationships, or is there people cheating? So if I look at this, I'm looking at my x values only. Nobody is repeated, so nobody's cheating. So yes, this is a functioning relationship. Now, if I look at example B, is there a functioning relationship or is there a cheating number? Well, if you look here, the 7 is a duplicate. The 7 has a relationship with the 8, but the 7 also has a relationship with the 9. Their relationship won't function. So this is not a functioning relationship. Now, it's hard to see when you're on a graph, but you can do what's called the vertical line test, because the vertical line will pass through the x point. So you can literally draw a vertical line through each point of the grid, on the grid, and if it only touches more than one point, or if it only touches one point at a time, then it is a function. If it touches 2 points at a time, when you draw a straight line, it's no longer a function. So let's see what that looks like. All right, here's another set, and we're going to put it in a table, graph, and map it all together. So for the table, we're just going to put the x values in one column and the y values in the next. So 2, 3, -1, 0, 3, -4, and 4, 2. And if we look at the x values, you can see none are repeating. So this is a functioning relationship. This is a function that we're looking at. All right, let's graph them. And we're going to graph these points. We're going to go 2, +3, and you have to count them because there's no points. There's no numbers on this coordinate plane. -1, 0, 3, -4, and then 4, 1, 2, 3, 4, 2. Now, if we did a vertical line test, I can actually draw vertical lines through each point, and none of them would intersect with each other. So that's what I mean by the vertical line test. So that works. And then we're going to map it. So I'm going to write all the x values here, and all the y values are going to go here. And then we have 3, a 0, a -4, and a 2. So 2 maps with 3, -1 maps with 0, 3 maps with -4, and 4 maps with 2. It's just all different ways of showing the same set. So let's look at how relations are functions or not functions. So the first one we're going to look at is a function. You can see that it has an equation, it has a domain, which is all the x values, a range, which is all the y's. It says a relation in which no two ordered pairs have the same x value, so there's no cheaters. So if I look at all the x values, I have nothing repeating, so that it is a function. If you do the vertical line test, you can plot the points -2, 5, 0, -1, 1, 1, 2, 1, 2, 3. And if we do the vertical line test, none of the points are on the same green line that I just drew. You can also map it. Remember, x goes in the first one, y goes in the second one. -2, 0, 1, 2. 5, -1, 1, 3. And they've just mapped straight across in this one. So that one works. Your domain is all the x values. The range is all the y. So -2, 0, 1, 2 is the domain. The range is 5, -1, 1, 3. Now let's look at an example that is not a function. They still have a domain and range, but the x value repeats when it's not a function. So if we look in the x row, you can see here 2 is in a relationship with 0, but 2 is also in a relationship with -3. This relationship will not function because the x is duplicate. Let's see what it looks like on a graph. If I go 2, 0, 0, 5, 1, -1, and 2, 3, now we can see the vertical line test. That last one, they intersect both on that same line. So that is not a function. With mapping, it's the same kind of thing. But because there's 2 in 2 places, I'm only going to write it one time. And then I'll write the rest of my y's. And you can see here 2 maps with 0, but 2 also maps with 3. So you can see that there's 2 arrows coming off this 2 here, which makes it not a function. And then the same thing for the domain. I only have to write it once, so I really don't have to write that second 2 because it maps to another value. And then my range 0, 5, -1, and -3. So you don't have to repeat it if it's already there. All right, so let's go through some of these questions together, and then some of them I'm going to set you loose on. So it says use a table to answer questions 1 through 4. So what is the range? Usually when you're looking at these, the first column is always your x, the second column is your y. So the range is just all the numbers in the y value. So it's going to be 50, 150, 200, and 250. And I'm going to skip down to number 3. The domain is all the x values, so 1, 3, 5, and 7. Now, it says the possible set of all amounts of time. So they're talking about that first column. Time is the x value, or the domain. And the possible set of distances you can travel is the y value. X comes before y always in a table. So in this one, Dylan works at a sandwich shop and he's paid $5 per hour. Complete the table for values shown how much Dylan will be paid if he works 2, 5, and 10 hours. This goes back to what we did with proportional relationships. If $5 is per 1 hour, how could I figure how much I made for 2 hours? Well, 5 for the first hour, 5 for the second hour is going to be $10. You could do 2 times 5. And the same thing here. 5 hours times $5 an hour gives you $25. And then you could do 10 times 5, which would be $50. And then 15 times 5, which would be $75. So it says explain how the relationship between the number of hours worked and the wages he can earn. Well, for every hour Dylan works, he earns $5. All right, so now's the fun stuff. And this is where I'm going to kind of start setting you loose. Determine whether each example is a function. And so if we look at these, I want you to try to answer. Remember, you're looking at the x values. Look at number 7. Is it a functioning relationship? Are there going to be any x's because they're cheating? Or does it function? So this one's not a function because the 3 is the cheater. 3 is going with the 1, but 3 is also with the 5. If you look at number 8, does number 8 function? Number 8 does not function because 2 is cheating. 2 has negative with 1, but 2 is also with positive 1. Okay, number 9 and 10 is where you have to do the vertical line test. Where can you draw vertical lines, and does it only pass through the graph one time? So this one is a function because there's no place that I can hit 2 points at one time. And number 10 is not a function. You're good with drawing lines until you get here or here. And then you start hitting multiple places at a time. And you can only hit once. So that one's not a function. All right, last little bit that we're going to go through. Remember, you look at the x value. So I recommend go through circle all the x values. Does this relationship function or is it not a function? And I want you to write the domain, which is all your x values, and the range, which is all your y values. So go ahead, do number 1, and then you can go ahead and do number 2. And here are your answers for number 1 and number 2. Remember, your domain is your x and your range is your y. You don't have to repeat the 4s for the range in number 2. You can just write 1, 4, because I know that that 1, 4 pairs with all those other domain values. And they are both functions. All right, let's talk about the graph one. If it is a function, find your x and y coordinates before you find the domain and range. So I could look at this graph and say, oh, I could do the vertical line test, and it would only touch in one spot the entire time. So it is a function. And it says, if it is a function, find your x and y coordinates before you find the domain and range. So let's make a quick table of x and y. And this is just like when we first started this lesson. Where does it intersect perfectly on this graph? And there's a whole bunch of spots. All right, so let's just write those down. I'm only going to write 4 of them. 2, 3, 0, 1, negative 2, negative 1, negative 4, and 3. That's plenty. The domain is all the x values. So we have 2, 0, negative 2, and negative 4. The range is all the y values. So I have 3, 1, negative 1, and 3. Oh, I don't have to write that 3 a second time because it's already there. So there's that one. And then I want you to do the bottom 4 all on your own. So I'm not going to provide you any guidance. I want you to pause here, do all 4. You can unpause when you're ready to check your answers. And here are your answers for those bottom 4 questions. If you're still struggling, make sure you go and see your teacher so that we can review this with you.